Hey guys, I got a nice little action that I've created here that can have a better weather effects than the standard CopperCube behavior. So this one I've created, you can rotate the particles to match the direction that the particles are going in, like rain or meteorites or whatever else. You can change the angle in either direction, X, Y, or Z. You can adjust the sound volume as you increase the current particles. So you start off with 0, or you can start off at maximum if you want, whatever you want. I just started off at 0 to so you can see it building up. It can adjust the fog automatically. It also has an impact spawn of a impact effect, like animated texture or something like that. It's also got player particle collision detection, so that's really the best thing about it. It's one of my best code improvements that I've found for my game anyway, because for a long time I haven't been able to work out in my game, if you go into a cave or under a building, how do you stop the particles going straight through the roof? Well, you actually can't unless you code it yourself like this. So this one's got impact rain spawn, like a little particle effect. This tells you the height to adjust, if it's a bit high or too low, how long to play it for. It's got an impact sound. You can play impact sounds as well if you want. I'll change that later on a different one, but for now it's got player particle collisions, and that is based off, so you got player height, width and relative height. That's based straight off the camera, collide when moved. In this case it's actually 11, 9, a relative position is 9, so it should be 11, 5 and 9. So if we go and change that, so that will then adjust the particle collision detection more accurately. Now, the way I've done this, I haven't used billboards or vertical billboards because you can't rotate those. So I've used just a simple 3D plane in an X configuration like that. So you can hardly even tell when you're playing it that that's what it's doing. It works quite well actually. Let me just put the rain back. This one I think it is. Yeah. So whichever angle you're looking at it, you'll be able to see it. It looks pretty much the same from all angles. Oh, there you go. It's a bit clearer there. Yeah, it works quite well actually. You can rotate this how you like. So that's using that. Now the size of this, in the player party collision detection, you need to know the size of what size do you want it to measure to get a more accurate collision. So what I've got is a behavior that just detects the size. So just select a mesh, just go Control M for measure, and it tells you the size X, Y, and Z. So that's 20 by 20 by 20. And if you notice the texture, it doesn't go to the far ends. It's close to the end on the texture, but not fully. So, in other words, I just back it off a little bit. So for a slightly more accurate particle detection, I'll make that about 18. So there it is there, 18 by 18. And there's the player collisions. So we'll just play that now and I'll show you. So I'll put that back, drop that in the ground. Okay, so I'll just play that now. So here's the frame rate. By default, my frame rate on my computer, I think on anyone's, it maxes out about 333. For whatever reason, if you put 75, it goes above 300. But anyway, so that's just to see what impact it has on a frame rate. I've optimized the code quite a bit to get that a little effect on the frame rate as possible, and this number here is the particle count. So I'll just play that. Okay, so to start it off, I push a button, W, and you can see the particles and the frame rate. The frame rate will go up to Okay. Because I'm recording the screen, it's dropped the frame rate a little bit, so just keep that in mind. It was 333. It's because of the screen recorder. Alright. Now, you notice I'm not using a that texture is not a single raindrop. It's better if you multiply the number of raindrops on the one texture so that you can get a more rain for the one particle, if you like, more bang for your buck. So you're not using so many particles to get the same effect. So there's, I'm increasing the particle count, so it's about 300, and the weather and the volume is going up as well. So you can see that. See the particles on the ground? And it'll make a sound when the player particle detection, like that's the impact sound. See under here, there's no, it's not coming through the roof, so that's good. There you go, see? And I can change the angle. See that? Change the angle. Now I'm getting wet there. But if I stand behind a rock, I'm okay. There you go, it works. So that works good. And I can change it back the other way as well. I might go back the other way. There you are. Going back the other way now. There you go, back under cover. There you are. That works. Yeah, so it's pretty good. Works pretty nice. Okay, so I'll just reduce the particle count. Okay. Yeah, so sorry for the yell. Just reducing the particle count. And as you can see, the sound goes down and matches the Oop, still getting wet. There we go. There we go. So that's done. It's finished. That action is cancelled. Finished now. So it's pretty nice. I think anyway. For my game, it's a long time I've not been able to work out a solution to this problem. But now with this, I can absolutely do however I like. So what you do is attach the player camera, attach the particle node that you want to play, the starting particles, the maximum number of particles, the maximum distance from the camera that you want the particles to spread out to. So if you want to see a lot of particles in the distance, then just increase the max distance. This is the starting minimum height and the starting maximum height. So if you want to see it from high up in the sky as well. Now this is the speed that it's coming down on each of the axes, the X, Y and Z. As you saw, I was adjusting the X speed manually by just using the left and right mouse button, but that's just you can do it how you like. All it does is increase or decrease the current particles by 10. Normally you just use code to do it more smoothly than that, so you may have noticed a little bit of jumping around in the background, fog and the rest of it. But yeah, but that was just for testing, so that totally works. That's how fast the main part of the game runs. The actual animation speed of the particle through the sky. I noticed if you change it to 50, it may increase the performance a tiny bit. It doesn't really make a big difference. But you might notice a slight jaggering of the particle as it's moving through the sky. as in slight jumping, very, very slight. So that's why I put it about 30 is pretty good. Or every second frame at 60 frames per second, or basically 30 frames a second. It's fine actually. So that's the sound that's playing in the background. If you want to add that, and the maximum sound, I could have turned that down. It was a bit loud. If you want to fog up according to the percentage of the current particles over the maximum particles, then just input the maximum fog maximum that you want, and it will automatically work that out. The impact spawn is the impact rain as it hits the ground, the particle effect. That's the height of the impact particle effect. If it's a bit too low, you can bring it up or down accordingly. So positive number will bring it up a little bit. Negative will just drop it down. You can either, so that's how long the particle effect will stay visibly for in milliseconds. If you want an actual impact sound, you can do that too. And how long, so there's the sound node that can be played. This is how long the sound will play for before it's despawned. Sorry, that's how far away from the player, impact sound distance, that the actual sound nodes will be cloned and make a sound from. So I've just put a limit on that in case it affects performance. I haven't really noticed much of a performance hit on that, so it's been running pretty good. But anyway, I thought I'd better put that in anyway. Impact sound time is how long it plays for before it despawns. So this is the player collision. So I showed you that before. That's the height, the width of the player. That's the relative height. You need those three in order to get the correct height of the player's head, top of the head, if you like. And this is just a rough adjustment on the actual size of the node that we're playing. So there's quite a lot of stuff there. Now if we can change that, we can change it over to, for example, a meteorite effect, which is pretty cool. Might just increase the distance there on that one. Now come that down at an angle 3 and down 4. So that's rain sound. We'll be change that over to meteorite sound. Fog, well, we don't need to fog it out. That's for rain really. Impact spawn, yes, we want to impact a nice, I've got a animated texture here. There it is, impact meteorite. So I've created that. I'll leave that to impact time. I can't remember. I think it needs to be 300 milliseconds for that. Impact sound, yeah, you can. This is a nice thing as well. You can actually put 3D sound effects for each particle as it hits the ground as well. So it's super cool. So impact meteor sound, yep. I already checked. This one needs 2 seconds. It plays for quite a while. And stick with the play collisions. Now the actual size of the meteorite is different to the rain for this particular one. So okay, it's under the ground, but that's it there. So the particle has to be straight down so that the rotation can rotate at the correct angle. If I go Control M, measure that, that's 10 by 10 by 10. Now the actual impact part of the meteorite is not 10 by 10, it's not the whole size, it's a lot smaller. So we'll just go say 5 by 5 approximation, stick with that. Yeah, okay, so that should be about right. So if we try that one, put that back under there. Okay, play that. So particles, oh, look out. Hey, look out. not bad, is it? Alright, well, that's done. Bit loud, that one, wasn't it? A bit too loud, but obviously you can change all those things, but that's pretty cool. I thought, anyway. I thought it was pretty cool. Notice how when you step over the edge, when it doesn't find any... Oh, that's interesting. Still going. I have to fix that. When you step over the edge, it can't, in other words, it can't find a collision impact. It will then just default to a basic bit further down from the player's height. It'll just create an impact. So, in other words, it doesn't break anything. Yeah, it works pretty good, actually. Yeah, so particle collision detection, impact nodes, impact sounds, you know, the whole bit. It's working pretty good, actually. I think, anyway. This is a massive improvement in my game, that I can use this in my game directly, this same code, to get proper particle collisions. You notice when I was running around out there, I didn't get hit constantly, but I did get hit quite a bit. The little beep 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 was going off about maybe 20 times. Yeah, so you can easily just add in, you know, other things into that. I'll put on impact, do an action, and then you can create how many other actions you want to do for the player, if you like. I'll add that in. Yeah, so hope you like that. You can pick it up on itch.io for only a couple of bucks, and yeah, hope you use that in your game. It's pretty good, I reckon. So we've got there's the it's an animated texture. I've just used the default CopperCube one for now. I could have used a shader to do that over a single texture, but this works pretty well, actually. Once you've got it in memory, it just cycles through it pretty quick. I don't know if using a shader in a single texture is faster or better. I'm not sure about that. Yeah, so, and you can get weather obstructions. You can hide behind rocks and things like that, so it won't go through the rocks. That's pretty cool. I thought that's a really nice feature. Now, with certain rocks, you have to be aware that some meshes, if you decimate it too much, I think it can stuff it up a little bit. My first rock I stuck in here, it was going through the rock, and nothing I could do could fix it. I could have probably tried to put it through Blender and fix it up, but the next rock I put in, this one, works perfectly fine. So in other words, some meshes are going to have, they might have some issues. So it won't necessarily be the code that's a problem, it'd be the rock or the obstacle that's somehow it's not quite right. But anyway, so this works perfectly fine. Now, for this roof on this one, the table collision, so the roof is only paper thin. So it's like, if you don't want the impact to show through the roof, because the particle effect is, it's like the, you know, it's a bit like three-dimensional in a sense, from the vertical point of view. Then all I've done is put a collide box over top of it. So there's the I've just taken a copy of the surface and just lifted it up a bit. See that there? So that's the actual collision for the roof, so that the particles you don't see anything coming through the roof at all. So there it is there. All it has is collision, and that's it. The actual table roof still has collision, but that actual top roof part doesn't need any because it's not used. So that's how you fix that. Otherwise, it's a bit awkward to try and prevent that from happening otherwise. I suppose there could be ways around it where you could lift up the actual impact particle height so that it comes, but then again, if you lift it up too high, when you're looking at the hitting other things, it'll be like floating in midair, like off the ground, and you look at it and it look weird. So that's why it's the best to do it that way. Put an invisible collision a couple of meters or something like that above your object that it's colliding with. With this rock, there isn't any. It doesn't need any anyway because the rock's pretty thick. But if it was a paper thin wall, then you would need to do that. Yeah. So there's a couple of nice tips and tricks. I think it's a pretty cool thing. It's saved me an enormous amount of problems. And also, when the particles are coming in at an angle, you can actually see them as they would pretty much look coming at an angle, like a dart coming at you. Whereas the default CopperCube particle system, it rotates it to face you all the time, so it's going to look a bit weird. Like, yeah, it's never going to be quite right. But whereas if you use what I've done is just two 3D plane meshes in an X configuration, it looks pretty good. I mean, if you want the most perfect, then you may go and upgrade it from two plane meshes in an X configuration to an actual low polygon 3D mesh. That could be even better, but it'll probably have to be pretty low polygon because you're cloning hundreds of copies of it. Yeah, so let me know what you think. I think it's working pretty good. For now, it's pretty nice. So pick it up on Ixchio and let me know what you think. Okay, I'll just show you the code. Now, whatever numbers you put here in the start of the action, they will use that. But some things can be overridden as a global variable. These are global variables, so the current particles during the game, during runtime, can be changed to whatever you like. All you have to do is change the current particles to 0 to stop it. So, see up here, change current particles to 0 to turn off the action. So once it'll count down until all the impacts are done, everything's finished, and then it will turn itself off. Play pause, you don't have to worry about that, it's automatically calculated. But the X speed, Y speed and Z speed can be changed anytime during the game, so whatever you like. So that's pretty nice. Change the direction and speed and the amount of particles. You generally don't need a lot more than that. Yeah, so that's just a little bit extra. Everything else is pretty much optimized in terms of speed and efficiency. It's yeah, it works pretty well actually. I don't think I'd optimize it any much more than what it is already. Yeah, so I hope you like that, and let me know what you think. Cheers.